Okay, last time we talked about classifying triangles with by how many sides are congruent or by their largest angle. Now we're going to look at how the different angles in a triangle relate to one another, okay? There's really three ideas here. The first is a triangle sum. So we all know this one, the three angles in a triangle sum to 180. But now we can prove it, and then we can start using it. We build on that and say, well then, if we know two angles of these triangles are the same, well then the third one must be the same. And we just use the Triangle Sum Theorem to prove that one. Okay, similarly, we use it to build further and say, and just to be clear here, we are saying that if two angles of this triangle match two angles of this triangle, the implication is then their third angles must be the same. And we'll talk about the proof or the reasoning behind that. The exterior angle theorem is again using the Triangle Sum Theorem, or we could even, Triangle Sum Theorem. And what we're saying is these two angles in a triangle always add up to be equal to this angle. And it's a simple little algebra trick. It can maybe save you a couple steps in a proof here or there, but it's not going to be necessarily a crazy thing that we use all the time. Okay, and that's going to be simple algebra. So those are the three simple ideas. Triangle sum, that they add up to 180. The third angles must be the same if two angles are the same, and the exterior angle theorem. Okay, let's go through them one by one. Okay, before we do that though, let's just develop language talking about interior and exterior angles. The interior angles of any polygon, right, we're talking about specifically a triangle, are those three angles inside aimed at the interior. They're formed by the sides of the polygon, right? Those are the normal angles we talk about in a triangle, right? Triangle, three angles. And then exterior angle, imagine you extended one of the sides, right? If you extend one of the sides, the angle between that extension and the consecutive or adjacent side, that forms an exterior angle. Now we could have extended this side and gotten another one, but those are vertical angles, so those are always going to be the same. So even though we now have two exterior angles created, so really there'd be 6 exterior angles of a polygon, we usually only talk about 3 because there's only 3 unique ones, right? There's 1 over here, there's 2 over here, there's 3 over here, right? So there's an A, a B, and a C. We don't talk about the duplicate copies as much. So we'll get to the sum of the exterior angles. We mean one exterior angle at each intersection or at each vertex. Okay, so that's what an interior and exterior angle is. All right, so the triangle sum theorem, the three angles of a triangle sum to 180 degrees. Notice I added the word interior because we're talking about the interior angles. So we could do a quick problem here, right? Where we simply say, oh, look at these x's and numbers. Solve for x. Well, we go, well, this angle plus this angle plus this add up to 180. So let's write that. We have x plus 2x plus 3 plus 52 equals 180. So the three angles there add up to 180. And then we just go ahead and solve. So combining like terms, we get 3x plus 55 is 180. So that's, 3x equals, we just subtract the 55 from both sides. So that leaves us with a 125. We divide by 3 on both sides, and we get x equals, that doesn't go in evenly, so let's just leave it as 125 thirds. Or if we needed to know for any reason, we could say, oh, well, that's actually 41 2/3, right? Okay, I like leaving it like this though. Now what's the reasoning here if we were to write the proof? And we absolutely could. I don't want to spend the time right now writing this proof, but basically all we do is we don't have to, but we could extend this side just for help, just to look at it and go, okay, so we got this big long side here. And then remember we have a postulate in last chapter where we said, given a line and a point not on the line, we could construct or we could add a line passing through that point that's parallel to this line, right? Because we're saying I have infinitely many lines through this point, but we could say, let's choose the one that's going in which direction? The direction of our other line, right? So that's it. So pass through that point in what direction? Parallel to that line. So we add that parallel line. That's called adding an auxiliary line. We can absolutely do that, and the reason we can add that is that postulate that given a line and a point not on the line, there is exactly one line passing through the point parallel to it. All right, now what we can do is go, oh, well, since we have parallel lines, we could say that alternate interior angles are congruent. So A along this transversal, right, if we were to extend this, is the same as A over here. Oh, look at that, okay. And then we could say same thing, alternate interior angles C is the same as its alternate interior angle here, C. And so look at that. Now we have a straight line creating a straight angle or a linear pair, sort of. And then what we end up getting is, and you do this in 2 steps, you'd say this angle plus this angle adds up to 180 because they form a linear pair. And then you'd use the angle sum to say, well, A plus B add up to this angle. So total, then you get A plus B plus C equals 180. So it'd be a little tedious on the algebra side, but that's how you would do it. So you construct that auxiliary line, then alternate interior angles to get the A and the C up there, and now you know the 3 angles sum to 180. Okay, so 3 angles of a triangle sum to 180. Well, then we also have this third angle theorem. So if 2 angles, if 2 triangles have 2 matching angles, so over here in this diagram, so we have 2 separate triangles where 1 angle matches, and just any other angle, so okay, so this other angle matches this other angle, so 2 of the angles match. Well, then what we're thinking is then the third has to match, and it's really easy, right? If these 2 triangles down here have an A and a B, well then what's the last one? The last one is 180 minus A and minus B. And over here in this other triangle, the other angle is the entire total of the triangle, 180 degrees, take away the angle A and the angle B. So of course, 180 minus A and B is the same as 180 minus A and B. So if we have 2 angles that are the same, we just subtract them from 180. And just by pure algebra, we get that the third angle must be the same. It's 180 minus those 2. And in the other triangle, it's 180 minus the same 2. So of course the third angle must be the same. That's called the third angle theorem, okay? Again, that's just helpful in the future for saving steps in a proof. So we're just kind of shortening, we're collapsing some algebraic steps that we might use later on. Okay, the exterior angle theorem, again, not something we're going to use all the time, but it saves us a few steps in a few places, is just saying that if we have this picture here, so we have one exterior angle, it's equal to the sum of the 2 remote or opposite interior angles, okay? So if you add up any 2 interior angles, that is equal to the exterior angle on the opposite side. Okay, now let's look at the y. You're like, that seems a little crazy. Okay, this is called the exterior angle theorem. So A plus B equals C whenever you have this. So if I drew the picture in a different direction, I said like, here's a 10 degree and a 20 degree, then you know this is 30, right? Well, let's look at the y. If this is A and B, well, then what's this angle right here? Well, triangles add up to 180. So this is 180 minus A minus B. Okay, that's this angle right here. Well, then, what's this angle over here next to it? I'll do it in like green. What's this angle over here? Well, these form a linear pair. So it's just, a circle. It's just 180 minus this. Well, oh, that's a little scary algebra, right? So we just go 180 minus this angle. And what's this angle? It's 180 minus A minus B. Right? And so then we go, okay, well, that's 180. We distribute the negative, minus 180. Plus A plus B, the 180 minus 180 cancels, and we get that other angle is A plus B. Okay, there we go. Good stuff. Another way to think about it, you don't need to think about it this other way, but another way to think about it is kind of if 2 angles are supplementary to the same angle, then they're the same. It's supplementary, this angle is supplementary to those, and it's also supplementary. So if, like, this isn't one angle, but if this combination A plus B and this angle here in pink add up to 180, you could think about it like the pair A and B is supplementary to this angle. And then also this forms a linear pair, so this exterior angle is also supplementary to that pink angle. And remember, if 2 angles are supplementary to the same angle, then they're the same. So that means this A plus B is the same as this exterior angle. So there's 2 different ways to think about it. All right, so let's use it here. Here's an example, and it says, oh, we've got a bunch of variables. Well, we just directly apply it. So 2 interior angles add up. This is A plus B equals C to be equal to the exterior angle. So here we have 2x plus x must be equal to x minus 3. And so this is 3x equals x minus 3. We subtract x, we get 2x equals negative 3. that is an impossible scenario. Let's change that to a positive, because we can't have an x be a negative. So let's change that to a plus 3, plus 3, plus 3. Let's divide by 2, so we get x equals 3 halves. Plugging that back in, this is 1.5 degrees, this is 3 degrees, and this over here is 4.5 degrees. So it all checks out. What is this other unknown angle here? Well, it's just 180 minus 4.5. So this would be 175.5 degrees. And you can check, is the sum in here 180? Yes. Is this a linear pair that sums to 180? Yes. So all that checks out. That's valid. Okay, there's two extra little corollaries here. We're not going to dive into them. I just supply them. But if this triangle adds up to 180 and this is 90 degrees, well, then that means these two angles add up to 90 degrees, right? We could just really quickly show that with algebra. So then we say those other two angles, the two acute angles, are complementary. So corollary is really just like one extra step on the proof. Like, it's not its own theorem. It's not like 5, 7, 10 steps. It's just like 1 or 2 steps. So it's like if we already did that theorem, we don't want to recopy the whole thing. We just want to add like one little step and be like, oh, like we go, here's this huge proof, and then, oh, here's this little consequence of it, this teeny little thing next to it. That's what a corollary is. It's this extra little additional theorem that's so small it's not a real theorem, okay? And then we kind of talked about this before. You can't have 2 obtuse angles or 2 right angles in a triangle, and that's because, I mean, you could use the triangle sum to literally show it, but if you have 2 right angles, these are parallel, and if you have 2 obtuse angles, the sides are going away from each other, so they're never going to form a triangle. Yeah, so you can't have 2 obtuse or 2 rights. At most, you have 1. All right, so let's just jump into homework problems now, okay? So the students are using the exterior angle theorem. So let's see. So in this picture, angle 1 plus angle 4 is equal to angle 2. That's exactly the exterior angle theorem. Yep, check. In this picture, right, you have this angle plus this angle sum up to be equal to the exterior angle of the third. Okay, now let's look. Angle 1 plus angle 2 plus angle, oh, that should have been angle 3. So the 3 angles of a triangle add up to 180 degrees. They mistakenly combined the exterior angle theorem and the triangle sum theorem. So they mistakenly said all 3 angles add up to 180, and then they used the wrong angle. Instead of angle 3, they used the exterior angle there. Okay, that was the mistake. So Kara made a little mistake. All right, so let's just find a bunch of angle measures here. So the measure of angle 1, 2, 3. So instead of looking for one specific angle, I'm just going to solve for every angle in the picture, and then we can answer these really easily. So first we've got this triangle that sums to 180. So 180 minus 23 and 32, that's 180 minus 55. So that leaves us with 125. So here's a 125. Or I could directly say exterior angle theorem. These 2 angles add up to be the exterior angle there, so they add up to be a 55, right? Or I could have said, oh, 180 minus 125 and found it was 55. So we could have used the exterior angle theorem there just to save us a little algebra. Okay, so now we got 125 there, 55. That means this is 55. That means this is 125. Okay, and we have this is 22 degrees here. They have an arrow pointing it in. And so that means that the last angle over there is just 180 minus the 125 and the 22 degrees, right? Because this triangle here forms 180. So we just go, that's 180 minus 147. So that's 33 degrees. So this is 33. And then we can just say which angle is which. So 55, 33, and, oh, and angle 3 is outside. So angle 3, we could do the supplement of this. So 180 minus 33 is 147, or we could add these 2 together and say exterior angle theorem says those 2 added together, 147 is angle 3. Okay, lots of ways to do that. Let's switch colors here. All right, now we'll do, let's do it, yeah, green, okay. So we want to find angles, so let's just do all of them. So we have a right triangle here that adds to 180, but again, if we know this is 90, really what we know is this angle and this angle sum to 90. So I could just go 90 minus. Okay, so 90 minus 25. That leaves us with 65 degrees over here. Okay, well we know this is also 90 because linear pairs sum to 180, or just perpendicular lines means we get 4 right angles. And then on the other side, we have the same triangle here. We have 65 and something adds up to 90. So we go 90 minus 65. We get that other angle here is 25 degrees. So actually, interestingly, then that means this is a right angle because those two add up to 90. Okay, let's do another one. So here we're doing the same thing. So we don't know enough information on this triangle. So that would be not a great spot to start. So let's start on the left. We've got 47 and 57 in a triangle, adds up to 180. So I know angle 1 is 180 minus 47 minus 57. So that's 180 minus, that's 90, 104. And so that's 76 degrees. So we got a 76 right here. And then we can fill in all of the things at this intersection, right? Vertical angle, 76. This is 104. This is 104. Now we move over to the other triangle, right? We're traveling across this triangle. We solved this portion, and now we're jumping over here. And we go, well, we got 2 angles, and so we can find the third angle. And so we go, okay, well, that means we got 180 minus 76 and minus 55. This time I'm going to combine these. So I'm going to go, that's 104 minus 55. So that's 49 degrees, I think. So that's 49 degrees. And then we go over here, we just fill in the numbers they were asking for. So, right, 76 degrees, 76 degrees, 49 degrees. Okay. Ooh, I like this picture. So it tells us in writing up here an extra message. So make sure you read the instructions. So 4 and 5 are the same. Okay. Now, where are we going to start in this, right? We don't have any information down here to start other than the angles are the same. And we don't have vertical angles here. This one doesn't go through. So angle 3 is not vertical angle with anything on the top, except for this. Oh my gosh, it is. That combination is there. Okay, so look at what we got here. This is good. We can go, so this line extended, this line extended. So angle 3 is vertical with this whole angle. So angle 3 is 69 plus 47, which is 116. So we know angle 3 here is 116. Now think about what this means then. So if this is 116 degrees, well, that's too big for this zoomed in. Okay, so if we got 100, I'm going to just change that to be smaller. So if we got 116 degrees, well, think about this. These two angles are the same. So let's call them x and x, right? So you go, oh, well, 116 plus x equals 180. So we could solve. We subtract the 116 and we go 2x's is equal to, that's what, 64. So x must be 32. Another way you could do it is just without writing it down algebraically. You could say, well, there was 180 degrees, and I already used up 116. So we take away 116 of them. That leaves us with 64. And you go, well, that 64 is split evenly between these, so let's divide that 64 by 2. It's the exact same steps I did, just without writing the algebra. Okay, so we get then that in that triangle, we have a, this is a 64, oh no, we divided by 2. This is a 32 degrees, and this is a 32 degrees. Okay, where are we going now? Where could we go in this picture? Oh, well, look at this. Now, this is sometimes hard to zoom out and see this big triangle. But see this big triangle? We have 2 angles in that big triangle. So we could find this third angle in that big triangle. So let's do that, okay? So in that big triangle, we've got 180 minus 63 minus 32. Okay, so that whole third angle here is 180 minus 95, or in other words, it's 85 degrees. So if that whole angle is 85 degrees, we could take away the 32. We could go 85 minus 32. That leaves us with 53 degrees. So I'm going to erase that. We've got a 53 degrees here, okay? Oh, and here we have a linear pair summing to 180. So 180 minus 116, that's 64 degrees, which vertical angle, 64 degrees over here. All right, and then finally over here in this one, we could do a couple things. We could use the exterior angle theorem to say 47 plus something adds up to 136. So we just subtract 47 from 136. Let's do it. Let's call this measure of angle 7 instead of question mark. So we subtract to the 47, and we get, oh, that's a hard subtraction. Okay, so we get 129 minus 40, I think that's 89 degrees. Okay, But we could also do that a different way. So let's do it another way here. We could also say, all right, well, this was 180. So angle 6 is 180 minus 136, or in other words, 44. So we got this is 44 degrees. And just to double check if coming this direction and coming this direction, we got the correct values, we just check if these meet up at 180 and go, yes, whoo, our two sides united together and we got a correct solution. So let's just check 89 plus 47 plus 44. So that's the 80 and the 80 is 160. And then plus the 9 and 7 is 16, plus the 4 is 20. Oh yeah, that's 180. Perfect. Check. It worked out. And then you could just fill in what all the angle values are over here. Okay, I'm going to pause this to go back to Zoom. But when I come back, we're going to do just two last problems here. The last one's on ratios, which is a really good problem that comes up a lot. All right, let's do these last two problems here, okay? So on this one, we've got some overlapping triangles here, which can be confusing sometimes. So let's do it. So we have to be able to see this triangle. We have to be able to see this triangle. We have to be able to see this triangle. So there's lots of different triangles you have to kind of flexibly use. So first I'm going to use this triangle sums to 180. And so we get 180 minus 33 minus 24. So that's 180 minus 57. So that leaves us with 123. So I'm going to erase this. And I put a 123 in here. That means 123 vertical angle. That means supplementary. We've got the 57 here. And we've got the 57 here. Well, now for the rest of the problem, I could just use those smaller triangles right here. So I could say, well, that sums to 180. So I'll just do 180 minus 95 minus 57. So that leaves us with 85, the first two. And then minus 57, that leaves us with 3528. Whew, getting hard to do this arithmetic in my head. Okay, let's do this one over here is 180 minus 109 minus 57. Subtracting these, we get 71 minus 57. That's 2014, I think. Yeah, 14. Okay, so we got those last degrees here, 14 degrees, and this was 28 degrees. Then you just fill in whichever ones you got. Okay, last problem here. So these are opposite rays, so it's just saying this is a straight line here. Okay, we got that. It's a straight line. So the total here is 180 degrees. That's useful information. The measures of 1, 2, and 3 are in a 4 to 5 to 6 ratio. So there's a lot of ways you could do this. Okay, what a 4 to 5 to 6 ratio means is the first two have a 4 to 5 ratio, the second and third have a 5 to 6 ratio, and the ratio from the first to the third is 4 to 6 or 2 to 3, right? But it tells you this is called an extended ratio. So instead of a ratio between two values, it's a ratio between three values. So there's a couple easy ways to do this. Like one is you say, well, that means total, there are, add these together, 15 parts total to this whole 180. So a lot of kids just go 180 divided by 15. That's what? That's what, 10 and 2? Is that 12, I think? So each of these parts is 12. So that means this one has 4 parts, 12. This one has 5 of the 12s. This one has 6 of the 12s. And so total, there were those 15 parts of 12 each. But then each individual angle ends up being 48, 60, and 72. And let's just add those up just to double check. That's 108. Yeah, that's 180, and that's in that ratio. Or a more practical way to do it a lot of times is if we see things in 4 to 5 to 6 ratio, well, the easiest thing to do is go, well, the ratio of this to this is 4 to 5, but I don't know what multiple of 4 and 5 it is. So let's just say times some multiple, right? Because the ratio of 4 times anything over 5 times the same thing, the x's will cancel out no matter what number they are, and you get a ratio of 4 to 5. But we start with that 4 to 5, and we go, well, we don't know what multiple of that we have, so let's just put that 4x and 5x there. Similarly, we'll do the same thing over here, and we'll say, well, the ratio of this was 5 to 6, but we don't know what multiple of 5 to 6, so we'll just go, oh, well, it's this, right? The ratio of 5x to 6x is always 5 to 6, because the x's cancel out. So we're just saying we started with a 4 to 5 to 6 ratio, and we have some multiple of it. We don't know. And then you go down here and you go, well, then we know that 4x plus 5x plus 6x equals 180. And so same thing, we end up getting 15x is 180. We get x equals 12. It's the same thing as over here. We plug it in and we get these three angles, right? So either approach, kind of just with algebra or kind of just logically reasoning it out in your head. This is a really cool problem, and we're definitely going to encounter this more. A lot of times they'll use a triangle. They'll say, oh, you have a triangle, and the angles are in a ratio of 1 to 2 to 4. What are they? That's a good test or quiz question. All right, I hope you enjoyed the video.